Right, in this lesson, we shall be looking at Euclidean geometry, and we shall have the opportunity, I believe, to do also analytical geometry, or what we call coordinate geometry. Oh, now in the diagram, O is the center of the circle. O is the center of the circle. K, T, and L are points on the circle. Here is K, here is T, and here is L. If you look at K, right, T and L are actually points on the circle. KT, KT, TL, KL, right, OK, OK, OT are drawn. OT intersects, right, so OT intersects KL at M. ST is a tangent to the second at T. ST is a tangent to the second at what? At T. STK is 36 degrees. STK is 36 degrees. And OKL is 18 degrees. Right, so you have OKL is 18 degrees. Determine, giving reasons, the size of the angle T2. Right, the angle T2 is the angle that sits here. What is the size of this angle here? Anyone? What do you think? The size of the angle T2, what is it? Anybody home?
Say it is 54.
It is 54 degrees. Right, well done, Tando. So because we know very well that a tangent, this one is a tangent, so it is perpendicular to the radius there. And the whole angle, therefore, is 90 degrees. So to get the angle T2, you need to say the whole angle minus the part. So it's 90 degrees minus 36 degrees, and this is a beautiful 54 degrees. Right, and the reason for this is because you must determine giving reasons. The reason is that tangent perpendicular, right, tangent perpendicular to radius. Tangent perpendicular to radius. Right, so next question. The next question is we want to find L. What is L? This side, the size of this angle here. I'm giving you time to a break. I'm giving you time to a break. Anyone else? We want to find the size of the angle L. Who can guess, please? Because we want to discuss, we want to think. Who can think with us here? What is the size of L? If you can't see, tell me, or you cannot hear us. Okay, what is the size of the angle L? Anybody? Anybody? Hey, no one home. Anybody home? Are we saying nobody's at home? You see, if you come home and you're like, anyone home, and it's quiet. Okay, so yo, this here. In mathematics, we learn that if there is a tangent to the circle and a chord means that it's a line like this. That is drawn from side to side of the circle, from circumference to circumference. If there's an angle between a tangent and a chord to the circle, it is equal to the angle in the alternate segment. So that in the end, then now, if you have this, right, then there's an angle now, you have exactly this. There's exactly this thing here. Right, so this angle here must be equal to this angle here. So this angle is also 36 degrees. So the angle L is 36. These are past examination questions, guys. They're not just questions I'm bringing to you. And the reason for this is because of the tangent and chord. Tangent and chord theorem. So we say the tan chord. A tangent is a line that touches a circle at most at one point only. A tangent is a line that touches circle at most at one point only, and you are seeing a tangent and a chord there. Next question. Okay, who has a question? If you don't understand, please ask. If you are lost, talk to us. Don't just keep quiet. Please, guys. I'm urging you. The next question now, I'm giving you Tando a break now. You can just watch. I want to hear what these other guys are going to say, because I know I spent some time doing geometry at 4 today. Right, but I want to see what the other guys are going to do. Like at this point, determine giving the size of the angle cot. This one. K-O-T. Cot. Angle K-O-T. What is the size of this angle? Anyone? Please talk to me. I want to hear you. Anyone except Tando, except you, Tando. I want to hear the answers. Yes.
Say, I think it's 72.
It is 72 degrees. Excellent stuff. Okay, it is 72 degrees because of the fact that there is this angle at the center, and then there is this angle at the circumference. And therefore, obviously, you know, we do this, there's a theorem like this. If you have this here, and then you have this. So if you have this angle and that angle there. So we have this angle here and that angle there. Right, so now, looking at this very carefully, if you have this, an angle like this, and then an angle like that, an angle at center and twice angle at circumference. So, and this can be drawn in many ways, okay? Because some of you guys are still covering these theorems in school. You know, your teachers are not yet at this level. Okay, now, this angle, it's twice that angle at circumference, in which case we can do this. We can move this point. If we move, because these points do not have coordinates, so we can move them. We do not have special positions for this. So somebody can draw it like this, and it really means the same thing as this, because if you move this point to a position that is here, then it looks like this. But in both instances, you have A, O, B, C. See the A, O, B. In both of these cases, we say that the angle at the center is twice the angle at circumference, so that angle AOB at the center is 2 times angle ACB. Or yeah, alternatively, you can just say angle O. Let me just call it AOB. It's safe like that because O can mean many things. But then you say AOB is twice ACB. Okay. Yeah, thanks so much. So that now we can have the angle KOT. KOT. Okay, they made the examiner rotated this diagram. They rotated it and said that it looks upside down. And now you have the angle KOT. So it is the angle at center. It is 2 times that. Angle at center, 2 times this. So in other words, KOT is 2 times 36 degrees. So the angle KOT is 2 times 36 degrees. And 2 times 36 is what? It's exactly 72 degrees. And because it is 72 degrees, what we then have is the following. The reason for this is that angle at center, because O is the center, angle at center is 2 times angle at circumference. Angle at center is 2 times angle at circumference. And that's the answer. Next question. In the next question, we want to do 8.1.2. And we want to prove that. KM is equal to ML. Km is equal to ML. We want to prove this, but how do we prove this? How do we prove this? Okay, we show how we can prove this. Okay. Obviously, there are a couple of ways to prove this. The way to prove this is the theorem we do in grade 11, and this is the theorem. The theorem says that if you have a perpendicular from the, here's a circle with a center. A circle has a center and there's a perpendicular line segment like this. This is theorem 2, this one. Okay, you can call it theorem 1b. Right, your teachers might call it theorem 1b. So if you have a perpendicular line from through the center, it bisects the chord. It bisects the chord. Okay, I had lost Pechelelo. I'm so sorry. I'm so sorry that I had lost Pechelelo. My apologies that I lost you, Pechelelo. I don't know how. Maybe it's the network. My sincerest apologies for having lost you there. Okay, but this lesson is recorded, guys. Even if your network is failing, because sometimes because of your area, the network might not be good. But the recording is going to be there, and I'm going to post it on the group, and you're going to be having access to the recording, and you can watch this. When you watch the videos, do not watch like a movie. You stop the video, you try the question, you check the answer, and so on. You stop and sort of proceed watching. Okay, but yeah. So this is the theorem, grade 11 theorem. If there's a perpendicular from center to chord, it bisects the chord. That is the story. So in other words, now we just need to show that there's an angle of 90 degrees. So we need to show that this angle is 90 degrees over here. But we already know KOT. What is KOT? It is 76 degrees. So that angle KMO, this one, we want to show that this angle KMO. Right, so we are doing 8.1.2 now. So to do 8.1, yes, please.
Angle O is 72.
Well done.
Yes.
Well done. It's 72 degrees. Thanks for realizing that, because obviously that's what we got earlier. We got 72 degrees clearly there. Okay, I'm glad that you are wide awake. And thanks for noting that. So that in the end, now we have KMO. We want to find angle KMO. Okay, KMO is this angle here. KMO. Because now we already have like two angles here, the 18 and the 72. So to get the third angle, we use 180 degrees minus the other two angles. So it's minus 18 together with 72 degrees. And the reason for this is that we're dealing with what? The sum of interior angles of triangle. So that in the end, KMO, okay, we have 180 minus these things here. What is it? 90. Because 72 plus 18 is what? Is 90. 180 minus 90 is 90 degrees. Okay, because now this angle KMO is 90 degrees. The conclusion, therefore, is that KM is equal to ML. Why? We say perpendicular from center to chord. We say perpendicular from center to what? To chord. And this is the answer. So KM is equals to ML. And so we have proven this. Where's the question here? Or where's the suggestion? Okay. But also, I mean, this reason can be a perpendicular from center to chord. But one thing that is very popular with the examiners, sometimes it is allowed to say line from center. Line from center, perpendicular to chord. Line from center, perpendicular to line from center, perpendicular to chord, bisects the chord. As long as It's a line from center perpendicular to a chord. It bisects the chord. It divides the chord into two equal parts. Okay, this sounds like good news. And we proceed to enjoy more mathematics. Next question. Just look at the next one. Here is something more nicer. I want us to look at similarity and proportionality. In the diagram triangle, RDS is drawn. RDS is drawn. ABC are points on RD. ABC are points on RD, RS, and DS respectively, such that AB is parallel to DS. Here is AB parallel to DS. Okay, the examiner showed them to parallel here. So yeah, we're excited. RB, the ratio of RB to BS is 5:3. RB to BS is 5:3. DC is 20 units. DC, yeah, here is D and here is C, and it's 20 units. They've put it for us. And CS is 12. CS is 12. Prove, giving reasons, that BC is parallel to AD. We need to prove that BC is parallel to AD. BC is parallel to AD. Okay. This is awesomeness. Awesomeness. Right. So what then do we do to actually prove this part? Right. So I'm giving you 2 minutes to think about this, and then we do it now together. 2 minutes, and then I'm gonna take your inputs, and then we're gonna put everything together and write the answer. But I don't want to just give the answers, because sometimes you'll be bored and you're gonna sleep. Think about what you can do to prove 8.2.1, and then we'll do it together. 1 minute, 1 minute, I'm giving you. Yes, we are back. We are right back. Okay. Is the Nombuso, are you done?
Yes, sir.
Okay. What did you do? 8.2.1? How did you do it? All right, never mind. RB, you're going to check your answer. First and foremost, we have that RB over, okay, we convert the ratios to, we convert these ratios written in this form, and we write them as fractions like this. So it's RB over BS. Right, and RB over BS is 5/3. And then now, because it was given, so you have RBBS. So which means it is 5x, BS is 3x. And then now we want to prove that this BC is parallel to AD. All right, so to prove this, we might just have to also show that this DC over CS. Right, so we're gonna do DC over CS. Okay, this is the proportionality theorem, guys. I'm just yet to even do some of the basics. Some of you have not reached this point. We're just doing this, but some of you have not reached this point, I know. Right, so now if you look at DC to CS, so what is DC here? DC has been given, it's 20. CS is 12. Simplify this fraction, because this one is an improper fraction, but the numbers are composite numbers. To simplify this, what you get? So if you divide by 4, 4 goes 5 times into 20, but 4 goes 3 times into 12. And then now you have this ratio of RB to BS is 5/3, and this DC over CS is 5/3. And the conclusion is therefore that RB over BS, right? RB over BS is actually equal to DC over CS. Okay, because why are they equal, these things? This RB over BS is 5/3, but DC over CS is also 5/3. So these things are equal to each other. And the conclusion is that because this one is like 5, okay, it's like 5. It's like 5, and this is like 3 when you simplify the 20 and the 12. Okay, 5:3, 5:3. So, and the conclusion is therefore that this line is parallel to that, which means that BC is parallel to DR. BC is parallel to RD. Okay, it is parallel to RD because of the converse. The reason is that it is the converse line parallel one side of triangle. Or you can say the sides in the same proportion. Sides in the same proportion. Okay, the fact that now BC is parallel to RD, it means we can come to this conclusion and say, therefore, BC is parallel to AD, like this. Okay. I want to speak about the proportionality theorem. The proportionality theorem is a very important theorem that you need to learn and that you need to master. Okay, some of you have not seen it. That's why I'm going to just talk about it. I'm going to talk about it in green color. So the proportionality theorem says that if a line is parallel to one side of a triangle, it divides the other two sides in the same proportion. So that if you have A, B, C, D, E, if this is the case, you have a line that is parallel to one side of a triangle, it divides the other two sides in the same proportion. And this means that same proportion means AD over DC. For those who have not seen this, is AE over EB. Okay, we're going to be doing a lot of these kinds of things in this lesson. And in other lessons, we're going to be doing all the geometry at once. Every lesson is going to have the geometry from the beginning to the end. So, yeah, you'll see like strange things, but yeah, forgive me because I want to cover everything that, the applications that you can ever see at school level in geometry. So now, obviously, we need to prove giving reasons that BC is parallel to AD, and we have proven that. Where's the question? Okay, this one is called the proportionality theorem. This statement that says if you have a triangle like this, then this is true. This is called the proportionality theorem. Proportionality theorem. Where's the question? Who has a question or who has a suggestion? Maybe there's a mistake you have seen there, that there must be a 2 somewhere where there's a 3. You let me know. The next thing we're going to do is 8.2.2. If it is further given that RD is 48 units, here is R Here is D. And now the examiner is saying it's 48 units. Calculate giving reasons the value of the ratio AD to AB. Right, so we continue. Okay, let's look at 8.2.2. How do we start? Right, how do we start doing this here? Okay, because you already know that this one is parallel to this one. What do we call this diagram here? Because if it is further given that RD is 48 units, calculate giving reasons the value of the ratio AD to AB. So you need AB. So we're looking at the answer to 8.2.2. What do we call this shape here? This one, ABCD. What do you call it from grade 10? This shape that is these opposite sides that are parallel to each other and equal. It's called a parallelogram. So we note therefore that AB must be 20, because if this one is 20, then AB is also 20. So this AB is 20 because we're going to need it here. So we can see that AB is 20. And the reason for that is that we are dealing with the opposite sides. Opposite sides of palm. Opposite sides of palm. But when you say opposite sides of palm, we say opposite sides. We mean opposite sides of a what? Of a parallelogram. Okay, the fact that now you have RD is 48, meaning that from here to there is 48. Right, so we just need to get in, but also we know that this one, RB to BS, the ratio of RB to BS is 5:3. So the RB is going to be 5x, and this BS is going to be like 3x. Okay, you can put anything here, any letters there. Because this one is parallel to this one can be 5y, and this one 3y, like this. Okay. 5y plus 3y is equal to 48. Okay, so you can use RD. Is 5y plus 3y is 48. Okay, it is given this. You have been given that RD is 48 units. Okay, it's given there. And then 8y, this one is exactly what? 8y. Because 5y plus 3y is 8y, which is 48. And therefore, this means 8y is 48. You divide by 8, you divide by 8, and the answer is what? Is y equals what? Y equals 6. Once you get y equals 6, then it would mean, therefore, that AD, excuse me. Right, it therefore means that AD is equal to what? AD is 3y. But what is y? It's 6. And this is what? It's 18. If AD is 18, then we are done. We then come and say this one, the ratio. The ratio of AD to AB. What is AD? It's 18. And then AB is what? Right, the ratio of AD is 18. And then now we know that AB is 20. You can divide these things by 2. If you divide 18 by 2, you get a 9. You divide 20 by 2, you get a what? get a 10. Right, so and this becomes the answer. And this becomes the answer. Here's a question. So we're to find the value of this ratio AD to AB. So it is exactly 9:10. 9:10. Where's the question? Where's a suggestion somewhere? Where's a suggestion somewhere, somehow? Right. A suggestion somewhere, somehow. No suggestion. We move forward. People are quiet. Come something easy. In the diagram, O is the center of the circle. ABCD is a cyclic quadrilateral. ABCD is a cyclic quad. You need to learn how to prove this one because it's in the exam 99.5% of the times. Use the diagram in the answer book. Okay, these are like past exam questions I've taken from like past papers to prove the theorem which states that the opposite angles of a cyclic quadrilateral. I keep losing you. I'm so sorry. I'm so sorry. I'm so sorry, Perrell. I keep losing you. I'm gonna be using both Zoom and Microsoft Teams pretty soon from this coming week, so that you can see the difference. Maybe some of you will love Microsoft Teams more than Zoom, but I'm gonna let you know in advance so that you can prepare. Okay, we start in the diagram. O is the center of the circle. Here is O, it is the center of the circle. ABCD is a cyclic quadrilateral. Use the diagram in the answer book to prove the theorem which states that the opposite angles of a cyclic quadrilateral are supplementary. That is proof that angle B plus angle D is 180 degrees. What is the first step? Anyone? First step. What do you do first? First things first. We do a construction. We do a construction. And we draw. We draw radii OA and OC. We draw radii OA and OC, like so. And then call this one 1 and 2, like this. Where's the question? Who has a question? And then now this is obvious for us. Right. Yes, dear. Yeah, that's fine. Yeah, because ubuyile urutla requesta. Oh, okay, okay, thank you, dear. Okay, thank you. Okay, yeah, we do the construction, and then after having done the construction, we... Right. Right. We continue. So draw radii OA and OC. And then if you draw radii OA and OC, and then you notice that angle O1 is equal to what? Angle O1, this one, is equal to 2 times angle B. Okay, this one is a theorem, it's a law. You like need to learn it like this, and the proof. You need to learn the proof. How to learn the proof? You read the proof and close it and make sure that you can do it on your own without looking at the answer. That is how you learn mathematical proofs. So angle at center equals 2 times angle at circumference. And then now you take the other angle O2. The other angle O2 must be 2 times angle D. So angle O2 is 2 times angle D. Angle at center equals 2 times angle at circumference. Okay. So angle O2 is 2 times D, but angle O1 is 2 times B. This one is a theorem. Theorems are laws that we use in mathematics. We call them theorems. Angle O1 plus angle O2 is 360 degrees. And this one is called revolution. Revolution, O1 plus O2 is 360 degrees revolution. But what is angle O1? Angle O1 is twice B. Is 2 times angle B plus angle O2 is 2 times angle D, and this is 360 degrees. Factor out 2 so that you have angle B plus angle D, then this is 360 degrees. Okay, which means that angle B plus angle D is 360 degrees, which you divide by 2. And if you divide this by 2, you have 100 and what? In 80 degrees. And the conclusion, therefore, is that angle B plus angle D is equal to 100 and what? And 80 degrees, which is what we're supposed to prove here. Because they said use the diagram in your answer book to prove the theorem, which states that the opposite angles of a cyclic quadrilateral are supplementary. And if you don't want to say the opposite angles are supplementary, that is proof that B plus D is 100 and what? And 80 degrees. Who has a question here about this one? It's a past exam question. Who has a question? These things come at grade 11, they come at matric. So you need to understand these, because these things are going to come in your grade 11 exam, they're going to appear in your matric exam at both grades. So it's very important that you understand these. Who has a question? Any question? Right. It's like no one has a question here. It's like we are dealing with people who understand these things. We are dealing with the geniuses. Are we dealing with the geniuses here? Are you dealing with the geniuses here? Okay. No one has a question. Or this thing is Greek to you, is Chinese. I hope not. Let's look at the next question. We're going to be doing geometry in its totality, but like everything. In the diagram, DEFG is a cyclic quadrilateral. DEFG. Cyclic quadrilateral means what? Means you have a circle like this and then a quadrilateral inside. Such that EF is parallel to DG, parallel like this. H is another point on the circle, such that DH is parallel to FG. You can see DH is parallel to FG. These double arrows here. Chord EH is drawn. Let's see. Chord EH. This chord is drawn. Let angle D1 be X. D1 is X there. Okay. This is good news. Prove giving reasons that angle D1 is equal to angle D2. Angle D1 is equal to angle D2. Want to try? How do you prove that D1 is D2 here? How can you prove? What is the first step? To prove that D1 is D2. Angle D1 is equal to angle D2. Angle D1 is equal to angle D2. What is the first step? Anyone who is feeling energetic? Who is feeling energetic? No one is feeling energetic. Hey. Anybody home? Anyone home? Because now when there's somebody at home, then the person at home is going to say hello when somebody's knocking at the door, at the gate, you know, and now the person is going to say hello. All right. But it's quiet here. Quiet, 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 quiet. Hey, how come? It's so quiet that there's no one. Okay, if your network is failing, guys, this lesson is being recorded, please. It's recorded at the source. And then since it's recorded at the source, you will have access to the actual recording. So you mustn't cry. You mustn't what? Cry. Right. Okay, first things first. We can find this angle here. We can say that the angle EFG is 180 degrees minus x. Because this one plus this one is 180 degrees. Okay, this is the story here. We said the opposite angles are supplementary. If you add B plus D, you get 180. As long as this quadrilateral has all the corners on the circumference of a circle. All the corners on the circumference of a circle. So this plus this is 180 degrees. Similarly, we just say that if you want to get this angle EFG, this one, you just say 180 degrees minus the opposite angle, okay? Which is a shortcut because you don't have a lot of time in the exam. This is true because these are opposite angles of cyclic quad. Opposite angles of cyclic quad. Right. So we continue. We continue. Right. We continue. So that in the end, then you have that this is 180 degrees minus x. (180 degrees minus x). Okay. Now, then what do we do here? If this is 180 degrees minus x, then what do we do? There are a couple of things that are very, very important for us to consider. But what then do we have to do? What then do we have to do? The angle EFG, right? The angle EFG, this one here, can also be seen as what? Right, so the angle EFG, which is this angle here, you can also know, you know from grade 10, right? If you have the C like this, and then this is parallel to this angle plus this angle. If this is A and that is B from grade 10, what did they teach you? They actually taught you to then say, yes, hello? Yes, my dear. Yes, my dear. Okay, that's fine. Yeah. What is your number 18? Yeah. Stand number. All right, my dear. All right. Thanks, my dear. Okay, my dear. All right, thanks, my dear. Okay. Right. So in the end, then you have these. Simultaneously, you can be able to see that okay, you can be able to see that you can engage and also be in a position to have the angle EFG differently, like EFG from grade 10. Okay, EFG from grade 10. This plus this must be 180 degrees. I was saying angle A plus angle B is 180 degrees. Okay, because these are, we call them what? Angles in C, we call them co-interior. Co-interior angles, if you have some parallel lines there. Okay, so that at this point, the EFG is equal to what? It's equal to 180 degrees. So the EFG is 180 degrees. So it is EFG plus G. If you say EFG, this angle F plus G is equal to 180 degrees, normally we can just say EFG is 180 degrees minus angle what? Minus angle G. And these are called the co-interior angles. These are called co-interior angles. Okay, yeah, okay. Yes. Yes, hello, my dear. All right, okay, okay, I think you check. All right, yeah, just try the thing now. Okay, try to finish the thing now, guys. I'm just sorting something here. Somebody, yeah, just try the thing now and then let me know. Let me know. Okay, yeah, I'm using my hands to punch something on a device here. So you're just 1 sec. Okay. Right. So y'all just try the question. We're gonna finish it just now. Okay. We're gonna finish it just now. Okay, yeah, we'll continue. So we have the co-interior angles. So that now the EFG minus G is equal to 180 minus G. So co-interior angles. Why do we have co-interior? Co-interior arise if you have parallel lines, and the parallel lines are EF. I keep losing, I'm just so sorry. So you have these parallel lines here, and these parallel lines are EF is parallel to DG. Okay, yeah, if I lose you, I'm just so sorry that I keep losing parallel there. But in the end, then please, the recording is available. So, right. So the recording is available even if you lose, we lose you, then you're gonna get the full recording and you're gonna be in a position to. Okay, in the end, then you have EFG, which is EFG. So yeah, but these things are equal to each other. Now the angle G and the angle D2, they are angles in Z like this. So this angle is equal to this angle. But angle D2 is equal to angle G. What is the reason for this? What is the reason for this? Okay, because D2 is G, it means that wherever there is G, we can put what? D2, which means EFG is 180 degrees minus D2, minus angle D2. Okay, try to think hard, guys. This is geometry, this. In the place of G, we've put D2 because D2 is equal to G. Why is D2 equal to G? These are alternate angles. Why are the alternate angles DH? DH is parallel to FG. Okay, we continue. We continue. We continue. Okay, now we take this equation, this one, and then we also take this equation here. Because it's EFG equals this, EFG equals this. So which means, therefore, you can say, therefore, 180 degrees minus X. 180 degrees minus X is equal to this one, 180 degrees minus angle D2. Okay, in which case, therefore, 180 cancels. 180 both sides, giving us minus X equals minus angle D2. Okay, it's negative, negative. Then it means that X is equal to angle D2. But D1, okay, let me write a little bit more steps. Right, so yeah. Okay, yeah. Just try to see, I'm gonna finish that now. Let me just speak to this guy here. Hello? Yes, yes, how are you? Yes, fine, thanks. Okay, just 1 minute. Okay, I think, yeah, I'm going to get these numbers. Let me just give you these numbers. 3023, Hashi Drive. 3023, Hashi Drive. Okay. Okay, we'll continue. Okay, look. Okay, I'm trying to help this person. Just 1 minute, please. Yeah, but also do an calling. Yeah, but now usisatuza nasesikoleni this guy. Yeah, useduze nasesikoleni unibhekile uyangifonela manje uthi hayi uthi ngasesontweni ne? Okay, yeah, let me see. Okay, yeah, just 1 minute. Let me see what I can do. Right. Okay, yeah, we continue, guys. I'm just trying to help this person who is looking for directions here. Okay, so in the end, then the conclusion then is that because X is that, then our X is D1, and this means that D1 is equal to D2. Since X is equal to angle D1. Okay, where's the question about this proof? Because we have to prove that D1 equals D2, and we've proven this. There are many ways to prove this, but this was just a one past exam question. So, right, think about this and let me know if there are some issues there. Right, please. So, right. Okay, yeah, this is the proof. What's the question about this proof? Who does not understand something, please talk to us now. You are lost somewhere.
Sir,
Yes, please. Because I want to make sure you understand this proof. It's a past exam question, this appears at grade 11 and it appears at metric. So I want everybody to understand this, okay? Because I'm dealing with grade 11s here. I'm also dealing with metrics, and that is why I'm mentioning the two grades. So you need to understand these things, both grades. And that is what the curriculum is saying that your teachers are doing in school. The teachers are doing this topic, and then they're going to be doing coordinate geometry, and we're going to be doing that together today. Yeah, any question? What is your question? Who is lost somewhere here?
Samina, I'm lost.
Where?
Like all the questions. Like,
Please
can you please summarize for me?
Please come again. Can I please summarize?
Yes.
Okay, we can try to summarize. Can I start from the beginning?
Yes.
I can erase and start again. You see, I can erase and start again. I can write it like differently, you know, and maybe it's going to be clearer. But in the end, you know, there are many ways to kill a cat. But in the end, I want you guys to understand these things because I want you guys to understand these things because it's not Greek. Yes, my dear. All right. I think I'm phoning at this guy. Let me try to call this guy. All right, my dear. Okay, thanks, my dear. All right, my dear. Okay, thanks, my dear. Okay, let us continue. I'm trying to help this person who is somehow looking for directions. They're a little bit lost and they're trying to. Yeah, okay, no apologies. This person is just disturbing me, but unfortunately, they are lost. Okay, now the couple of things that are very important. So now let us do this again from the beginning. Let us do this again from the beginning. Let us do this again from the beginning. Okay, to do this again from the beginning, the couple of ways that we need to use to actually do this particular question. Right. And so the way we can do this is as follows. We have seen that we're able to prove it earlier, but using like a different approach. And so we can prove it now using a different approach. Okay, first, because this one is X, we use it. We use the fact that opposite angles of a cyclic quad. So if you have a quadrilateral like this, if you have a quadrilateral like that, then the opposite angles, A, B, C, D, you'd have therefore that you have that angle A plus angle C, for example, is 100 and what? Is 180 degrees. So this is exactly what you need to establish here. Okay, and also you can say A plus C because they're opposite, but also you can take D plus D up, D plus B. That is what we did here, B plus D. B plus D was 180 degrees, and these are the opposite angles of a cyclic quadrilateral are supplementary, and this is the meaning. Right, so yeah, let us continue to prove this. So now then we come here and we then say, okay, we want to prove it now. Okay, yeah, we are starting from scratch. So we're gonna deal with this one plus this one. So you're gonna say like, can just say X plus angle F, X plus angle F. Instead of saying F, you can just say EFG, but it's just F. Okay, so X plus F is, because these things are like, this is a cyclic quad, this, because all the vertices lie on the circumference. So now then you have these, which are opposite angles of cyclic quad. So all right, so we continue. We continue. All right. So in the end, then you have this plus this is 180 degrees, which are opposite angles of a cyclic quad. So, but you can solve for EFG here. So EFG is 180 degrees minus X. So we just use the fact that the opposite angles of a cyclic quad are supplementary. But this is giving us X, uses X here, and X is D1. So we have D1, but we need to bring D2 into the picture, and we need to mix this up with D2 so that we can get D1 equals D2. But D2 is sitting here. The only way now we must bring D2. D2 must now be brought this side of the diagram. But now, clearly, now we can see this here. Okay, so we're able to see this pattern. And these angles in Z are called alternate angles. Okay, so we can say, okay, Mr. Examiner, what we're able to see is that D2 is equal to angle G. You can just do that. D2 equals angle G. D2 equals angle G. Yes, please. Oh, okay. Yeah, but this guy is just, yeah, he's about to help you now. Just 1 minute. Yeah, just 1 minute, 1 minute, 1 minute. Okay. Let me see. I think maybe this one. Okay. Let me see. Let me just try to reach this one. Yeah, okay. I'm just trying to help this person quickly in just 1 minute, please, because it's like they're stuck. Yes, Horisani. Yes, Horisani. Now, I've sent you a cell phone number with the message there on your messages. Please just contact that person because that person is the person you need to pick up. They're in zone 2. This is the person.
Remember them outside.
Yeah, but you see, the problem with outside is they can't see you sometimes. That's why I've sent you that cell phone number. Okay. All right, we're right back. We continue, guys. Yeah, I'm sure the person is going to be okay now. Right, so let us continue. Let us continue and answer the questions and become the best we can be. And this is the day that the Lord has made, and we're going to rejoice and be glad in this day. So, yeah. Okay, I was saying then D2 is G. So D2 is G. Right, if D2 is G, we are excited because of the alternate angle. Let's put a reason for this. These are alternate angles. Why are they alternate angles? They're alternate angles because DH, this one, DH is parallel to FG. DH is parallel to FG. Next. Next. So we have that this one is equal to that one. Okay, now we are close to the answer, but we must now connect star G and F. And the way to connect them is to use grade 10 because there's a parallel line here, parallel line there. These lines are parallel, and then now these are the kinds of angles that are in U like this. And how do we connect angles in U? We call them co-interior angles. So now we're going to add them up these. Right, when we add them up, right, so we're going to say EFG. Because these are parallel lines, these are angles in U or yeah, in C, you say F, EFG plus angle G is 180 degrees from grade 10. These are called co-interior angles. Why are they co-interior? They're co-interior because of parallel lines here. So this is EF parallel to DG, like this. But this D2 is equal to G. D2 is equal to G. And therefore, it means, therefore, we can say, therefore, plus D2 is 180 degrees. which is 180 degrees minus D2. Okay, so therefore in the place of G, you can put what? Right, I lose you sometimes. It might be the network, guys. Please forgive me if I lose you. I'm going to be using like 2 softwares from this coming week. I'm going to be using both. I'm going to be using both this one and Microsoft Teams. Okay, now we're going to take this one, call it 1. And this one, call it 2. And from this, we were able to say thus. Okay. 1 equal to 2. 1 equal to 2, which means that 180 minus x is equal to 180 degrees minus D2. And you cancel this. 180 cancels out, which means minus x is minus. Okay, 180 cancels out, which means that minus x is equal to minus D2. Minus x is minus D2. And in the end, what then are we having here? Negative cancels out, and when you cancel the negative out, it means x is equal to angle D2. This means that angle D1 is equal to angle what? D2, which is what we have to prove, that angle D1 is equal to angle D2. Okay, so if I lose you, forgive me, this lesson is being recorded. If your network is bad, because the network sometimes, we can't control it. The quality changes, and from time to time, but this is recorded and you'll get quality recording. So that is awesome. So yeah, do not be like scared or anything. Do not be like scared or anything. Okay, yeah. So do not be afraid if I lose you. Okay, we have been able to prove that D1 equals D2. Okay, I started and I looked at slightly different approach, but in the end, it's like the same thing. It's like exactly the same thing. We move to the next question, guys. Okay, I'm trying to go deeper in geometry. Even tomorrow at 4 p.m., we shall do geometry. And then, let me see. Hello, guys. Yes, guys. Is it? All right, all right, all right, all right, all right. All right, all right, that's fine, that's fine. Okay, Danke. Okay, yeah, I'm trying to just help this person. It's like they're getting lost, my goodness. Hey, these guys. Right, so in the end, at the end, we have D1 equals D2, and we've been able to prove it. Let's move to the next question. The next question is a past exam question like this one, and we are in a position to continue. We're in a position to continue. We're in a position to continue. Let's just continue and do this one. Okay. In the diagram, TR is the diameter of the circle. So you have that TR is the diameter of the circle. Okay. PRKT is a cyclic quadrilateral. Okay. So if you have PRKT is a cyclic quadrilateral. And we continue. chords TP and KR. Chords TP and KR are produced to actually okay, we'll continue. Right, so chords TP, here is T and here is P. Chords TP and KR are produced to intersect at S. Chord PK is drawn such that PK, okay, let's check. You have PK is equal to TK. Okay, the examiner marked them here already. Marked them here. These are equal. So TK is equal to, or PK is equal to TK. Proof giving reasons that SR is the diameter of a circle passing through S, P, and R. S, P, and R. I'm giving you 1 minute. 1 minute. Okay, 1 minute. Let me know when you're done. If you can't see, talk to me, please. Okay, so yeah. Okay, yeah, please. 1 minute. If you're done, let me know then that you're done. If you're not done, let me know. If you're done, please let me know that I'm done. Okay, let me know when you're done, guys. Right. Yes, who is done? Who is done? Okay. Nombuso, are you done?
Sir. No, sir.
Okay, yeah. Parallel, I know that you might get this one right. But I know that you might have not covered this yet, you know. Proof giving reasons that SR, are you able to see SR? Or you cannot see? Okay, you are, I hope you're not sleeping. Okay, let us prove this one because it's too easy. Right, we are looking at 10.1.1. We're looking at 10.1.1. Right. Right, so in 10.1.1, there are a couple of things because you were told that TR is a what? TR is a diameter. So here is T and here is R is the diameter. So a diameter in mathematics is always like this. So if you have a diameter subtends an angle of how many degrees at circumference? And it subtends an angle of 90 degrees. So this one is the diameter. It subtends or it forms, it spans an angle of 90 degrees at circumference. So this is a diameter, it spans an angle of 90 degrees. This is a diameter, it also spans an angle of what? This diameter here spans an angle of 90 degrees here, 90 degrees there. But this one is a straight line, these. Why? Because they said chord TP, chords TP and KR are produced to intersect at S. So if this chord is produced, it is a straight line V, so that you can have these angles here must add up to 180 degrees, adjacent angles on a straight line. So in the end, then you first things first, you can see that TPR angle TPR is 90 degrees. Angle in semicircle. Angle in what? In semicircle. Angle P3. Therefore, angle P3 is also 90 degrees. Why? Because this plus this must give us 180 degrees. These are adjacent angles in a straight line. This is a straight line here. So that this one is 90 degrees, so P3 must also be 90 degrees. Why? Adjacent angles on a straight line. Hey, these guys, my goodness, today they just give me headache for no reason. Just 1 minute, let me just try to speak to this person here, because now they're just getting stuck here. Is it? Okay, let me check. Okay, I already check. Okay, sharp. Okay, so we continue. We continue. Okay. Right, so as we continue here to prove this one, let us prove this with ease. So this is these are adjacent angles on a straight line. Right, so yeah, we're good. Next point. What do we do next? So in the end, then you have this one is 90 degrees. Right, so why is P3 equal to 90 degrees? It is 90 degrees because these are adjacent angles on a straight line. So we continue. We continue. We continue. Right. So in the end, then, what do we then have here at this point? So if this angle is 90 degrees, then you say, therefore, SR is the diameter. Therefore, SR is the diameter. So in the end, then, what we're having is therefore that SR is the diameter. Why? This is the converse angle in semicircle. Converse angle in semicircle. Okay, it is the converse of that result, angle in semicircle, because we say that if there's an angle in semicircle, and well, the word semi means half circle. So a half circle is a circle formed by, that is divided by a diameter. So a diameter subtends an angle of 90 degrees as circumference. But we then say the converse is that if you have that this angle is 90 degrees, it is subtended by a chord, then this chord here is a diameter. Is the diameter. So right, that is the converse of that result. Is the diameter of a circle. Right. So yeah, just note that. So we've been able to prove this first one. Okay, now let us continue. Let us continue. Let us continue. Right, try the next one, 10.1.2. I'm giving you like 2 minutes to try it, and then we shall discuss it together. Try 10.1. Try 10.1.2. And let me know when you're done. You're supposed to prove in 10.1.2 that angle S is equal to angle P2. Please let me know when you're done. All right. Right. How far? Nombuso. Are you done? Nombuso, are you done? Hello, are you done?
No, sir.
Okay. It's a bit hectic. Try to think about this. So yeah. Right. So how far? Who is done? Hello, guys. Yes, my dear Nitolile. Yeah, okay, yeah. This guy is trying to locate you. Just give him a few minutes, okay? He's trying to find you guys. Yeah, my dear, he's trying to find you guys. Yeah, just give him a few minutes because this guy has arrived, but he's trying to locate you. Yeah, just because I'm trying to. All right, yeah, because the guy, there's a guy who is waiting there. Right. Okay, yeah. Try please to do that one. Guys, I'm actually. Okay. Right, Nombuso. I keep losing you. Why? I keep losing Nombuso. Yeah, okay, I'm saying do this one. Please do 10.1.2. Do 10.1.2. Let me know when you're done. If you can't see, talk to me. If you can't see. Right. Right. Who has proven that? You need to prove that angle S is equal to the angle P2. Who has proven that? No one. Okay, let us go together. Let's, yes, who is done? Okay, people are sleeping. I hope not. Right, to prove that, so we're looking at 10.1.2. Okay, we start with the fact that now this angle here, the angle R1, it's the theorem we do at grade 11. if you have a quadrilateral like this angle is equal to this one. We say the exterior angle of cyclic quad. Exterior angle of cyclic quad. Right, so I'm looking now at this one. So this angle here is equal to the interior opposite angle. So this angle R1 is equal to this one. Right, so that is what we say. So in other words, you can say that angle R1 is equal to the angle R1 right is equal to the angle PTK. Angle R1 is equal to PTK. And the reason is exterior angle of cyclic quad. Exterior angle of cyclic quad. So in other words, if you have a quad like this, the exterior angle is equal to the interior opposite angle. Next. Next. So which means therefore now we know that the angle P1 is equal to this angle P1 is equal to the angle PTK. The angle P1 is equal to the angle PTK. So we said, yeah, this equal to this, exterior angle of cyclic quad, but angle P1 is PTK. Angles opposite equal sides. Right, so in other words, because this one is equal to this one, it means that this angle here is equal to this angle here. This is the property of what you call isosceles triangles. So if this side is equal to this side, okay, let's isosceles triangles, you remember them. So an isosceles triangle is a triangle that is like a pair of sides equal. So if this side is equal to this, it means this angle is equal to this. So yeah, this side is equal to this means this angle equals this. So that P1 is equal to this angle here. These angles are equal, angles opposite equal sides. Now, then in the end, it means therefore that you have a the angle P1 plus P2, this one, from grade 10. C1 is equal to A plus B. C1 is equal to what? A plus B. And then in grade 10, we said that is the exterior angle of triangle. Exterior angle of triangle. So that in the end, then You have angle P1 plus P2. And angle P1 plus P2, this one here, because you're looking at this triangle, right? You're already looking at this triangle. P1 plus P2 is equal to R1 plus S. P1 plus P2 is R1 plus S. P1 plus P2 is R1 plus S, like in grade 10. And the reason is exterior. Exterior angle of triangle. Exterior angle of triangle. Now, with this mentioned, what then do we have? P1 is equal to R1. Therefore, P1 is equal to R1. Okay, therefore, right, you can come here and then say angle P1 plus angle P2 equals, so in the place of R1 is PTK, and this is also PTK. So in other words, it means that R1 is equal to P1. So in other words, wherever there is R1, you can put anything. Okay, there are many ways to do it. I mean, yeah. So we can even come here first and do this. You can write this step here. There are many ways to write these things. Okay, we're trying to do geometry, and this is yeah, a very interesting topic. R1 is PTK, and this P1 is PTK, and you can draw a conclusion that therefore angle R1 is equal to angle P1. Right. Okay. And then now we go on to draw the fact that angle P1 plus angle P2 is equal to angle S plus angle R1. And this is the exterior angle of triangle. So we continue. We continue. So that now at this point, R1 is P1. So you can come here and write angle P1 plus P2 plus angle S. And then R1, you put P1 here. Wherever there's R1, you put P1. Which means therefore that angle P2 is equal to angle S. But also, I mean, it's symmetry. You can also say angle S is equal to angle P2. Angle P2 is S, or S is equal to P2. So we've done 10.1.2. Where's a question about 10.1.2? The answer is there, and there is the proof, but who does not understand it? Who does not understand it? Who does not understand it? Who is lost? The next thing we're gonna do is to do the third one. So we proceed to prove 10.1.3. We proceed to do 10.1.3. Right. So 10.1.3, now we need to prove this result. How do we achieve that result? How to achieve that result? Right, let's continue. So to do 10.1.3, okay, thank you. Okay, thank you. Okay, thank you. Right, you're looking at 10.1.3. So we're gonna say in triangle SPK. Right, in triangle SPK and triangle SPK and triangle PRK. So let us look at those triangles. There's SPK, and then there's PRK. PRK. Right, so we want to prove this. Now let us prove this together. But if you look at the fact that you have SPK and you have PRK, clearly K2 equals K2. And this is a common angle. This is a common angle. Okay. Right. So, okay, right, the 2 points, just 2 minutes. Let me just. Hello? Yeah, let me just open for somebody who's knocking. Right. I'm coming now. Just try to finish that quickly. Yeah. Hey, my dear. Yes, my dear. Oh, all right, my dear. Okay, just 1 second. Okay, my dear. Yeah, yeah. Okay, we're right back, guys. I was trying to help this person who was just knocking. Okay, right. Okay, let's look at these together. I want to do this very quickly. But now the angle K2, because if you look at the triangle SPK and PRK, they both have the angle K2. But also, angle S, we've already shown here, this one. So in the triangle SPK, the angle S is equal to the angle P2. And that is that was proved in 10.1.2 above. Next, okay, we're proving, to prove this one, you need to prove that this triangle and that triangle are equiangular triangles. This is called the similarity sign. So now we want to prove that the triangles are equiangular, their angles are equal to each other. Okay, once you are dealing with triangles and you have two angles that are equal, then the third angles automatically become equal to each other. Right, so, and then you'll come here and then say, you have already dealt with the angle K2 in the SPK and PRK, and then you have also dealt with the angle S equals P2. But if you look at the PRK, we have not mentioned this angle. And when you look at the SPK, we have not mentioned this angle. So we mentioned those angles, and the way we mention them is to say that the angle SPK is equal to the angle, this one, PRK. Even tomorrow we're going deeper in geometry. I'm just getting your minds shaken here. And the reason for this is that it is the sum of angles in triangle. Sum of angles in what? In triangle. Therefore, the triangle SPK is similar to the triangle. Okay, now S is P. Okay, S is equal to P. So yeah, you do SP. The angle P in SPK is the angle R. K2 is K2, so K is K. All right, so yeah, and this now is, that is the answer 10.1.3. And then we say, what is the reason for this? The reason for that, this triangle is similar to that triangle because of angle, okay? Angle. So we have the angle statements that have just been established, and we are done with the proof of this one here, okay? So just note that, and we're excited about the proof. Then we continue to do the next thing. We continue to establish the next thing. Right, so in the end then, if it is given that SR is equal to RK, SR is equals to RK, so S is this one, R is equal to RK, you need to establish that ST is equal to the square root of 6 RK. So we need to prove that one. Let us prove this last bit, and then we can do other geometries if time is going to allow us, and then you guys have like a lot of the energy. But first things first, we're going to start with 10.2. First, we use this result. So we say the triangle SPK is similar to triangle PRK. Do not confuse this sign with congruency. Okay, when you say triangle ABC is congruent to triangle PQR, and this one you did at grade 10, this. And none of you is doing grade 10 at the moment. So this one, these horizontal lines, they mean congruent. There are 4 cases of congruence we learned, but this one is similarity. Similarity is what you do at grade at the FET after grade 10. So now, this one, to do 10.2, you just say this triangle is similar to this one. Why are they similar? Okay, tell the examiner that this has been proved in 10.1.3 above. Okay. And once you say it has been proved, okay, now you come and do this. Then you do this, that, these, that, these, that. Which means SK, rather S out with SP. Right, so you have SP. SP over PR. SP over PR. You start with the first two, SP over PR. It must be equal to, then you come with the next two, PK over RK. Equals, then you come with the first and the last, SK over PK. Like this. Right, so you're going to see the importance of this, but at the moment, what we're going to do is you can take this part out. Then now we're going to, if you cross multiply here, it's going to be PK, which is going to come out as PK times PK is PK squared. So if you cross multiply PK times PK is PK squared, then if RK is K, okay, yeah, I'm trying to conclude and see if you can do other things. So yeah, we have been able to establish that part. And then the next thing is to use Pythagoras theorem, because we want to find ST. This is S, T, and this is K. But because this one is a diameter subtends an angle of 90 degrees at circumference. This is also a diameter. This is the diameter passing through the center. It subtends an angle of this diameter spans. It spans an angle of 90 degrees at circumference. Right, so we're able to say ST squared. ST squared is SK squared plus TK squared. And this is Pythagoras. So we have ST squared. What is SK? Right, SK, you already know that SK is this one, but it is the same as the sum of two things, SK. Right, so SK is the sum of two things. So which means that SK can be seen as 2RK. So SK is 2RK. And then you square this. And then TK is equal to PK. PK. And this is, obviously it is given. So wherever there is TK, you can put PK. So TK is equal to PK TK equals PK given. So in the end, then let us write at the bottom. Let us write at the bottom. So which means that we have ST squared equals the 2 squared. What is 2 squared? It's 4. RK squared plus PK. Right. So if you have PK, PK is this one. Right. So if you have PK, then you need to continue with the results. Right. So if you have PK, then what you do with the PK? PK squared, excuse, here it is. PK squared is equal to SK plus. So wherever is PK squared, you can put SK by RK. Okay, like this. Which means ST squared is 4RK squared. Plus, what is SK? Right, so SK is 2RK. Which is 4RK squared plus 2RK squared. What is 4 plus 2? 6RK squared. So which means that at this point you have ST squared is 6RK squared. Right, so you take the square root both sides of this. And by taking the square roots both sides, we're able to establish what is wanted. The square root of ST squared is ST. And this is equal to the square root of 6. Square root of 6 times RK. Which means this is the answer. ST is equal to the square root of 6 times RK. And we have been able to prove 10.2. Where's a question about the proof? And who needs to know anything? Who needs to know anything here? Who is lost? Who is lost? Nombuso, any question? Tehelelo, you're confused. I'm left with Tando. Tando,
Yes, sir.
I'm left with you now. I lost the other guys, but it's okay that I lost the other guys. I think that, yeah, let's just conclude our discussion. It's 14 past 10. Right. Thanks a lot for joining us. We're gonna have another lesson tomorrow at 4 p.m., another one at 8 p.m. So yeah, we're gonna also be doing science tomorrow. Okay.
Okay, sir.
Thanks a lot, Tando, and have a good evening. And from us to you, good night.
Good night.
Good night. Goodbye, Tando.